This is a challenging high school problem from algebra. If x plus 1 by x is equal to minus 1, what is the value of x to the power 5 plus x to the power 4? So I'll show two ways of solving this problem, and each way is unique and can be described as a little bit tricky. So this is one of the, I'd say, harder high school algebra math. But let's start with this basic equation that we are given: x plus 1 by x is equal to minus 1. So we know that x is not equal to 0 because we have x in the denominator. So we can multiply both sides of this equation by x, and this is what we get. X squared plus 1 will be equal to minus x. And then if we bring x over to the other side, this is what we get. X squared plus x plus 1 is equal to 0. And I've put this in red because this is a result or an equation that I'll be referring back to as I proceed to solve this problem. So from here on, there are really two things that you can do. So one of the things is you have a quadratic equation, and whether you go for the solution or not. So that's the question, right? So you can always solve a quadratic equation, but this particular equation, it's going to be messy because the root that we are going to get is not a simple root. It's going to be a complex root. And for those of you who are well familiar with complex numbers, this equation must be very, very well familiar, because this is basically the equation for complex cube root of 1. But we'll tackle this problem in a way that we don't have to deal with like quadratic equations, or we don't have to actually deal with complex numbers. So what do we do from here? Well, one thing that we know is x is not equal to 1, because we can substitute 1 on what we have given. So we have basically x plus 1 by x is equal to 2, and that doesn't equate to minus 1. So we know that x is not equal to 1. So x minus 1 must be a non-zero quantity. And we know that the equation that we have, that will still hold if I multiply both sides by x minus 1. So if I do that, it's easy to recognize that what I have on the left-hand side is now basically x's cube minus 1, and that's equal to 0. And from there on, I basically get x's cube is equal to 1. Now, x's cube is equal to 1 doesn't necessarily mean that x is 1, because in this case, it's definitely, we already saw that x is not equal to 1, because x could be a complex number. And this is where it's a little bit probably outside the zone of routine high school algebra, but because this is a little bit different, because we are not dealing with a real number, it's a complex number. But again, this problem can be solved without using any knowledge or any formula or any math from complex number algebra. So this part has been pretty simple, right? So now what we do is we take our expression that we have been asked to evaluate, which is x to the power 5 plus x to the power 4, and we can just break it up. So x to the power 5, we can break it up as x squared multiplied by x's cube. And similarly, x to the power 4 can be broken up as x to the power 3 multiplied by x. And x to the power 3 or x's cube is 1. So whatever we have here, if we substitute x's cube is equal to 1, this is what we get. So we have x squared multiplied by 1 plus 1 multiplied by x. And that equates x squared plus x. And now we refer back to that earlier result or equation we had, which I highlighted in red. And according to that, x squared plus x plus 1 is equal to 0. So x squared plus x must be equal to minus 1. So x to the power 5 plus x to the power 4 is equal to minus 1. So this is one way of solving this. But there is also another tricky, fun, and maybe a little bit easier way of solving this. But it's definitely tricky. So in that particular method, what I do is, I start with this expression x to the power 5 plus x to the power 4. And then what I do is I just, strategically add and subtract certain terms. So I can write this as x to the power 5 plus x to the power 4 plus x's cube. I've added x's cube, so to maintain parity, I subtract x's cube. And I now add another term, negative x squared, and one more, negative x. And then I have to add those back just to maintain parity. So I have, added back plus x squared plus x. So basically, the expression that I have, it's the same as the one I started with. I just, added and subtracted a few terms, and I made sure that I have, I subtracted the same terms I added, or I added the same terms I subtracted, right? So that I have, parity. So what I'm now left with is x to the power 5 plus x to the power 4 plus x's cube minus x's cube minus x squared minus x plus x squared plus x. So from here on, I can basically take, for the first three quantities, x to the power 5 plus x to the power 4 plus x's cube, I can take x's cube common, right? And what I'm left with within parentheses is x squared plus x plus 1. The next three quantities, minus x cube minus x squared minus x, I can take minus x common, and then within parentheses I have x squared plus x plus 1, and then finally at the last at the end of the expression we have basically x squared plus x, right? So we still keep that. Now I refer back to the red equation that I earlier wrote, right? X squared plus x plus 1 equal to 0. So this becomes x cubed multiplied by 0. The second term becomes minus x multiplied by 0, and then we are left with x squared plus x, right? And then again from that red equation, x squared plus x is negative 1. So we are left with just negative 1. So this is another way of arriving at the result, a little bit unconventional way, I'd say, but it's still maybe a trick that you may find useful in problems like these.